Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and today I'm going to be talking about the concept of zero. Can anyone talk about nothingness? Well, we're going to try and do that today. So let's start. Now, a lot of you have been told that zero is a number. Okay, zero is a number. Is it really a number, do you think? Well, first of all, you'd have to have a definition for a number, wouldn't you? So you'd be stuck there already. You wouldn't be able to say whether zero is a number or not. Now, if you think of all the dunces in the math departments of MIT, Harvard, Oxford, Cambridge, and all the other Ivy League universities, they would very readily tell you that zero is a number. Okay? But and then they'd say, well, if you have no money in your bank account, right? You have no money. You have $0 in your bank account. Actually, no. If you look at the word have, it's a verb. Okay, it means you possess something. You do not have anything in your bank account. Zero is not anything. Zero is nothing. Okay, so you don't have $0 because there is no such thing as $0. There isn't a note like that which says $0. Okay. You don't have $0. You just don't have any dollars. If you need 3 apples to make apple pie and you have none, does that mean you have 0 apples? No. It means you have no apples. So 0 is not a number because a number is a name given to a measure that describes a ratio of magnitudes. Okay. So, and it comes to us, by the way, from the brilliant ancient Greeks. I hate to say this, and I'll say it as many times as I need to, because it's true. Number is not something you get to choose, pick, or decide. Okay. Number starts off with a magnitude. Let's call this a line segment. It's got a magnitude of length. And we can't say anything about that line segment until we compare it to another. All right, like that. Then, because the ancient Greek language had pretty good words in it, like metrici, which means measure, and logos, which means ratio, all these things were easy to understand. So they would call something like this a ratio because all it means is the comparison of this line to this line, right? So, right at this very point, ask yourself, can you have nothing here, no magnitude here, and a magnitude there, and then tell yourself, well, how would you measure nothing using this part? Okay, because that's really what happens when you get a number. Let's say that this antecedent here, this part here, is twice this part. Then this part here measures this antecedent twice, and we get the number 2 corresponding to this over 1 or just 2. But how on earth are you going to measure 0? Okay, what are you going to do? Are you going to write, oh, the count, you're going to say this is the equal part, and here you have 1 equal part, and here you have. No, you don't have. You don't have anything there. Okay, you can't write 0 there. It's wrong. Okay, you don't have zero magnitude. It's impossible. Okay, so what are the uses of zero? Well, its main uses are disambiguation in the communication of numbers. So if we had a radix, let's put a radix point there, like base 10, which is 1 over 10, 1 over 100. I didn't mean to do that. Let's say units, tens, hundreds, etc., right? If we had a radix template like this, we'd never need to use anything but the digits, 1 through 9. We wouldn't even need 0. Okay. We could, for example, say 19 or 190. Let's say, 190 is just that. But now if you had to just write that down without a radix template, without this, you wouldn't know what that is. That could be 190, it could be 1900, could be 109, it could be 1009. It would make it very difficult to comprehend the value or the measure that we're trying to communicate. Okay? So what I'm telling you is that with the radix template, we wouldn't even need to use 0 at all. But it's pretty useful because we don't carry around a radix template. And so we're able to communicate all the natural numbers, 1 through to as many as we like, 10, 20, 30, etc., 31, whatever, using 0 as a placeholder. And it's also neat to use 0 when you have an equation, x plus 2, and let's say that's equal to y. Let's say that you want to find out what x is if you don't have y. Then you put a 0 there, right? If you don't have y, then what is x? X is minus 2, right? Does that make sense? Okay, so 0 is a placeholder or a disambiguator in communicating the value of number. It's not a number. You cannot add, you cannot divide, you cannot subtract, you cannot multiply by 0. That's nonsense. Okay, because multiplication is defined in terms of division. And you can look at my other videos to understand more about that. In fact, I give you the entire derivation of arithmetic. Now, you may say to yourself, well, who the heck were the ancient Greeks anyway, and why do they even matter? Well, let me tell you why they matter. Because if they didn't think the way I've just shown you like this, you wouldn't be able to do any arithmetic with fractions or anything. Okay. So for example, if they didn't think the way they did, you wouldn't be able to say P over Q divided by R over S is the same as P over Q times S over R. You wouldn't be able to say that. You wouldn't even be able to say P over Q plus R over S is the same as PS plus QR. Okay, and if it's a minus there too. You wouldn't be able to say things like that. And these are not defined by the dunces at MIT or the set theorists in Norway or the group theorists in Sweden or some other place. These are independent of what you think, of what God thinks, or what any other human or alien thinks. It has no effect on how these work. Okay? They're eternal. They've always been that way. They are that way right now, and they'll continue to be that way. You cannot create another system of arithmetic. So that's why what the Greeks said is so important, and why I keep on going back to what they said, because believe it or not, modern mathematics hasn't progressed since the ancient Greeks. It has retrogressed. It has gone backward, not forward, but backward. I mean, you can ask a dunce at MIT what is a number, and he won't be able to give you an answer in a simple sentence. He'll tell you, oh, it's some mathematical object or some hand waving crap about uh, a mathematical object that has certain properties like commutativity and associativity, and it's a field with two operations, or, I mean, endless garbage that has nothing to do with mathematics. How do I know? Because when this stuff was realized, it's not invented, by the way, when it was realized by my brilliant ancestors, they didn't have any of this nonsense that you find in mainstream mathematics today. And there was no such word as framework. Now, framework is a word you'll see in AIs often. Okay. The reason framework is there is that these morons who are part of the mainstream math community are no longer sure of themselves. Okay. So they'll say, oh, but Gabriel's calculus only holds in his framework. That's absolute bullshit. Okay. I don't have a framework. Framework is a word that belongs in engineering. It doesn't belong in mathematics. There is no framework in mathematics. There is geometry, and out of geometry we get geoarithmetic, which is the precursor, geoarithmetic. It's a precursor of arithmetic, but there is no framework anyway. Okay, we're not dealing with a structure that we're going to place an engine on, an axle, whatever else is involved in engineering. I'm not an engineer and I don't care. So, framework is a buzzword that a lot of AIs use. It's a hand waving buzzword. And it's a result of dunces at MIT, Oxford, Cambridge, Harvard getting involved with the pre training of these AIs. Okay. So, we have these highly stupid people who are pre training the AIs that are causing significant damage when a student gets on and asks a question and they receive a whole lot of absolute drivel from the pre-trained data of these idiots. Okay, why do they do this? Because their PhDs would be rescinded if they didn't. They don't have PhDs in mathematics. They have PhDs in mythmatics. So let's begin to summarize. Zero is a useful concept. Okay. It's useful in the sense of being a placeholder and disambiguator. And it's certainly more useful than saying, let's say, alpha as one, or beta as two, or beta I as whatever, 20, or whatever else. I don't know. It's definitely a good way of writing numbers. But a radix template, incidentally, doesn't represent all numbers. In fact, it doesn't represent most numbers. A base 10 radix template will only represent numbers that have 1, 2, any product combination of these in the denominator. So if PQ is the number, then Q must not contain any other prime factors excepting these, and 1 is a prime number. It's the prime number, contrary to what the morons in mainstream tell you. Morons such as Terence Tao and all the others. So, yes, these must be in Q. And when you convert, I was going to sign off, but I'm going to show you something else quickly. When you convert a number into decimal, so for example, when you say a quarter, you're not doing any actual division here. When you say it's equal to 0.25, what you're saying is that in your radix template, you have 2/10 and 5/100. Okay, and that is the measure of a quarter in base 10. And how do you get it in base 10? Well, you multiply it by 10 over 10. And And no, it's not because of a law or a principle of commutativity or associativity or crap like that that you can say this. It is because of the fact that multiplication is defined in this way. That is, if you say P over Q, or rather, if you say P over Q divided by R over S, multiplied by R over S, that means P over Q divided by S over R, or R over S divided by Q over P. It means both. Okay, it's because of this, not because of commutativity crap that your moronic math lecture tells you or your teacher. And it's also because of this that you cannot multiply by zero, because you'd have to at some point have zero on the denominator. Okay, so anyway, you switch these around, and what do you get? You get 2 plus a half, right? Times 1 over 10. And then that becomes 2 times 1 over 10 plus a half times 1 over 10. And you can multiply both of these so that you get 10 over 100. And then again, that's 2 times 1 over 10 plus, and you switch these two around, and that becomes 5 times 1 over 100. And these are the significant digits that you find. So you're measuring the fraction, and you can measure a quarter in base 10 because a quarter has the prime factor 2. It's equal to 2 times 2. Okay? That's why you can do it. You can't measure a third in base 10. 0.333 dot 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 is not equal to a third. It's impossible to measure a third in base 3. It's also similar to the drivel where they say 0.999 dot 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 is equal to 1. That's garbage. Okay, because this here is not a number. It's shorthand for a series. And yes, they'll tell you no, but we, as if they're the authority. We, the high priests of mainstream math academia, proclaim that is the limit. Okay, I don't care what they say. They're absolute dunces. They have soiled mathematics with their anti-mathematical garbage of set theory, topology, real analysis. In fact, they ran out of ideas of how to rigorize calculus. They couldn't rigorize calculus, so they turned to set theory. Okay. And then, of course, they followed the Bourbaki Luddites, those 40 prize French idiots who decided that because they didn't understand the ancient Greek foundations, they were going to redo them. And they created this edifice, which you now have to learn in a course on real analysis. So what I'm telling you right now, people, is the truth. It is fact. It's indisputable. You cannot argue against me because I am right. And if you think you are right, you have to prove to me that I'm wrong. Good luck with that. You better come very well prepared in order to debate me, because the majority of you have been trained by cranks. Okay, your math teacher, your lecturer, they're all mainstream cranks. And what is a crank? A crank is someone who cannot be convinced even in the face of overwhelming evidence. Basically, mainstream math community is a religion. It's a cult. They don't care about truth. They don't care about what you think. They care about their formalism. Okay, and formalism is authority. Authority has no place in mathematics. You cannot do mathematics or learn mathematics through authority. It's learned through reason and common sense. Okay, you do not do mathematics with laws and rules. There are no laws and rules in mathematics, because mathematics is not a human created thing. It's not even a divine created thing. I know that's a pretty big statement, but trust me. Well, no, don't trust me. Examine what I tell you, and you'll find out someday, if you have enough brains, that I've been telling you the truth. If you're not already subscribed to my channel, become a subscriber, click like, follow me on Academia.edu, where I'm one of the top readers. Okay, this channel, see, I mean, the top 0.5, hundreds of articles. In my latest article, by the way, which is really a fantastic article, I explain to you how the Greeks realized the concept of number. And become a members only subscriber to my new calculus channel. Instead of having millions of subscribers, I only have 3.8K, which is a shame because this is the absolute best math channel on the web. And look at the stuff I've shared with you. I explain to you why calculus works, and you vote me down, and you refuse to study the material I give you. That's a shame. Terrible shame. Okay, I'll leave it at that. Till next time, I'm John Gabriel, and if you haven't joined the new Calculus Discord, join it now. You'll learn a lot. Take care.